Alright, welcome to Saxon Math Course 3, Lesson 97, Recursive Rules for Sequences. So we're going to get started with some vocabulary. First off, a sequence. A sequence is an ordered list of numbers that follow a pattern. We write it in the formula a sub n equals a number, such as 3, times n. Now, with that, a sub n is the value. The value is the number that we write in the list. So whatever number we write in the list, that's the value. Now you'll notice that that's the whole thing, a sub n. But we also have the n over here. Now the n is sometimes called the subscript. It's called the subscript because it's written below the a, and because we're going to substitute it in for n in the equation. It's the position. Now n is the number that represents the place in the list where you can find the value. Now, it's our position. That's something like our first term, our second term, our third term. It's our n. So the first term would have an n of 1. The second term has an n of 2. The third term has an n of 3. Our new vocabulary word for today is recursive formula. A recursive formula is when the value of the term is based on the value of a previous term, not just the position. Now, if you're given a recursive formula, you must be given the value of the first term. You need that first term's value in order to get things started. Since every term is based off of the term before it, or even further back, you need that first term in order to find it. So what we've done before might have looked something like a sub n equals n times 2. So then our first term, a sub 1, would be 1 times 2, which would be 2. Our second term would be a sub 2, so we do 2 times 2. And you can notice that for each of these, I'm plugging in its position for n. So since we would plug in the position for n, we would say that the value is based on the position, because we find the value by multiplying the position by some number. What we're going to be doing now is going to have something along the lines of a sub n equals a sub n minus 1 times 2. Now that might sound a little bit tricky, but that just means every term or any number is equal to the number before it, because position, if we had something in third position, 3 minus 1 is 2. The number before the third one is the second one. Times 2 will give us the third one. So, the value of the term before it. We also, remember, need to have our a sub 1. If we were writing this same equation, we would write a sub 1 is 2. So then the second term would be 1 times 2. The third term would be 2 times 2. And the fourth term would be going on like that. Now, going into example 1. Example 1 says write a recursive formula for the following sequence. We're given the sequence 2, 4, 8, 16, 32, and then an ellipses. Remember, the ellipses just means that it goes on forever and ever and follows the exact same pattern. Now, a sub 1 is just the first term in the sequence. The sub 1 here just means the first term. Now, looking here, the first term is the one farthest to the left, so it's 2. Now, a sub n is the formula that we can use to find any term, and we want to write a recursive one, so it's based off of the one before it. So we can start off with a sub n equals a sub n minus 1, and then we have to look, how would I get from 2 to 4? Well, there's two possible options. There's a common difference and a common ratio. The common difference we would find by subtracting or adding. The common ratio is by multiplying. From 2 to 4 could be plus 2 or times 2. And then all we have to do is say the next one, 4 to 8. Well, 4 to 8 is times 2, not plus 2. So it's times 2, times 2, times 2, and times 2. So every term is the term before it times 2. So we would say that any number is the number before it times 2. We could also say 2a sub n minus 1. Now, in example 2, it says this formula shows us how to find any term of a sequence. So this is the explicit formula, it's not the recursive formula. It says a sub n is 1 plus 2 times n. So here we have a sub 1, because we're finding the first 4 terms. The first term is a sub 1. We're just going to substitute the subscript into the place where the n was. So here there's a 1. So we have a sub 1 is 1 plus 2 times 1. 2 times 1 is 2, plus 1 is 3. We're going to substitute the subscript. We're going to have 1 plus 2 times 2, which is 5. We're going to substitute the subscript again, which 1 times 2 times 3, 1 plus 2 times 3, 6 plus 1 is 7. And substitute subscript. We're going to get a 4 here. 1 plus 2 times 4 is 9. So this is 3, 4, 5, 7, and 9. Now, we need to notice here, if we're writing a recursive formula, is there a constant difference or a constant ratio? Now, with this formula, if we look just at the first 2 terms, 3 to 5 would be plus 2, and there's not really a multiplication here. We could try maybe times 2 minus 1 for this, but looking here, does that work in the second one? No, it doesn't. It doesn't work to get from 5 to 7. So, looking here, we have plus 2. So, our constant difference is plus 2. So, each term is the term before it plus 2. So, we would say that any number, a sub n, will be equal to the number before it, a sub n minus 1, plus 2. And that's example 2. All right, we're going to move on to example 3, which is our final example. A recursive formula for a sequence is a sub n equals, a sub 1 equals 5, and a sub n equals 3 times a sub n minus 1. It wants us to know what the first, well, we know what the first term is, it's 5, it tells us right here, what the next 2 numbers are, so a sub 2 and a sub 3. Now, since we know that it's a sub n minus 1, well, a sub 2 minus 1 is a sub 1. So a sub 1 is 5, so we're going to substitute in a 5. So we have 3 times 5, which is 15. Now for a sub 3, it's 3 times whatever a sub 2 was. Well, we found a sub 2 up here was 15. So we're going to do 3 times 15, which is 45. So this sequence would look like 5, 15, 45. And that's example 3. Alright, please remember, watch the practice set video. Watch the star problem videos. Come to the tutoring session if you need help. Come to the tutoring session and just tell me that you're doing well and that you don't need help if that's true. But please, come to that live Zoom conference. Make sure you're showing up. Make sure you're doing your work. Stay safe, do your homework, and wash your hands.